Hi, everybody. It's Professor Mitchell, and we're here doing trigonometry, chapter 1, section 1.1, which corresponds to assignments 2 and 3. So this, if you're in the online class, is assignment 2, is to watch this video, and then assignment 3 is your homework. Okay, so our objectives in this section: we're going to review plotting points in the rectangular coordinate system. So that's something that I'm sure you've done before. Graphing equations in the rectangular coordinate system, you've done that before. Most of the stuff in this section you have probably done before, but it's not a bad idea to review it beginning of a new semester. It's maybe been a long summer or been a long winter break, depending on when you're watching this. So these, I think, are all of our objectives. Okay, so the rectangular coordinate system, as you remember, consists of a horizontal and a vertical line that looks like this, right? So you have, on the one hand, your, where is it? Here we go. Okay, that was supposed to be something else. I want spotlight. There we go. So this vertical line is your y-axis. The horizontal line is your x-axis, right? And then right in the center you have, please stand by. You have your origin right in the center. Figured out what the problem is. Okay. And then when you mark off your axes, of course, positive numbers go to the right if you're on the x-axis. If you're on the y-axis, they go above the origin. Negative numbers go on the left on the x-axis and below on the y-axis, right? Okay. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers. You call the first one x, call the second one y. Or you call the first one your x coordinate and the second one is called your y coordinate. So in just a second here, we're going to review how to find specific points and how that works. Okay, so for example, the point -2, 4 means start at the origin, go 2 units to the left of the origin, that's the -2, and then go 4 units up, 1, 2, 3, 4. So there is the point -2, 4. This is in quadrant 2. I don't think that I have this written down in here, but at some point it might be helpful to remember. Over here is quadrant 1, and then it goes counterclockwise. Quadrant 2, quadrant 3, and quadrant 4, right? Okay. So coming up is another example of plotting a point. So I'm going to ask both the people that are in this room and also the people watching at home. Think for a minute about where this point is located. So hopefully you have a picture on your paper or in your mind of where the point 4, -2 is located. If I can get, there we go. Yeah, so it's, get my spotlight back here. So you start at the origin, go now 4 units to the right, and then 2 units down. So that is in quadrant 4. All right. Graphs of equations. So when you have an equation that has an x and a y in it, that usually describes a relationship between x and y. And you can draw a picture of that relationship. It's called a graph. You've seen this before. So for example, y equals 4 minus x squared is an equation that we can graph. Okay, so the way that we graph these equations is we find solutions. So a solution of an equation in 2 variables is an ordered pair that makes the equation true, all right? So for example, we were just looking at the point 4, -2. 4, -2 would not be a solution for this equation because when you put it in, it would not make the equation true. It would make the left side come out to -2, and I think it would make the right side come out to -12 or something, right? 4 minus 4 squared would be 4 minus 16, which would be -12. Okay, so our first example graphing is going to be to graph y equals the absolute value of x plus 1. And the way that I'm going to graph that is I'm going to pick some values for x. And what we often tell you is that you can pick any values you want. When we get into graphing specific kinds of equations, we often have some advice about what are the most helpful values of x to pick. But technically, you can pick any values you want. So we're going to try integers from -4 to 2. So the way that I have this set up is I've got this chart mostly blank. And I am going to, well, we will fill out the first, I don't know, 2 or 3 lines of this. And then I've got it all filled out on the next slide. Okay, so now I get to try my tablet and see if I can make that work. I think I want to get rid of Spotlight, and I want to, where did I see this? I think I want, where is it? Annotate, I want a pen. Where's the pen? Oh, I want draw. Okay, let's try this. Okay. So the way that we're going to figure out the y coordinate that goes with x equals -4 is, I think I'll be editing that part out. Okay. Let's try that again. La da di da di da. Okay, where is clear drawings? Clear drawings. Come on now. Here we go. Why isn't it doing it? Clear drawings. Okay, well, we'll try to ignore that. Okay, let's try this one more time. So y equals, see, I'm glad I'm not doing the whole chart. I need some practice with this pen. Okay, so the absolute value of -4 plus 1, which is the absolute value of -3, and the absolute value of -3 is 3, which means the ordered pair that goes with that is -4, comma 3. Okay. Let's try that at least one more time so that we all get the practice with finding the ordered pair and I get the practice with using the pen. I think I will do one more negative number. Let's do -2. I'll skip down here. I swear I did not press anything there. Okay, y equals the absolute value of -2 plus 1. -2 plus 1 is -1. The absolute value of -1 is 1. So the ordered pair that goes with that is -2, comma 1. Okay. And like I said on the next slide, I've got this all filled in. I think I'll skip down now to a positive number. Let's say 1. Hello. Y equals the absolute value of 1 plus 1. 1 plus 1 is 2. The absolute value of 2 is 2. That's what absolute value does, right? It changes negative numbers to positive, but it leaves positive numbers alone. Okay, so 1, comma 2. All right, so those are 3 of the ordered pairs that are on my graph. So now when I go to the next slide, you'll see this chart is all filled in. And it's a lot easier to read, especially when I get rid of my drawings there. All right, so I'm going to use those ordered pairs to make my graph, and that's all done on the next slide. I definitely need more practice with the pen before I start drawing the graphs, but we will get there. Okay, so here is the point -4, 3. That was one that we found. Here's -2, 1. I think that was the next one we found, and over here is 1, 2. This is typical for an absolute value graph. It usually comes out looking like a V. Okay. All right. Let's see. Okay, so next is intercepts. You have x-intercepts and y-intercepts. So the most important thing to remember, and you'll hear me say this over and over again, really anytime we're graphing, the x-intercept of a graph, well, first of all, that's the point where the graph intersects the x-axis. The way that you find that point is to set y equal to 0. Notice the y-coordinate of an x-intercept is always 0. And that's because it sits right on the x-axis. It doesn't move up or down. And then the same kind of thing is true for y-intercepts. Y-intercepts sit on the y-axis. They don't move left or right, which means the x-coordinate is always 0. Okay. So x-intercept set y equal to 0, y-intercept set x equal to 0. Okay, so here you have the graph of a line, and they want me to identify the x and y intercepts. X-intercept sits on the x-axis. So here I see one point that sits on the x-axis, and that is the point -3, 0, right? So if I start at the origin, that point is located 3 units to the left, but you don't go up or down because it's right on the x-axis. So that's -3, 0. And the y-intercept, you go up 1, 2, 3, 4, 5. So that would be at 0, 5. If you're doing homework on my math lab or on any kind of online system, just pay attention to the instructions. See, and for example, if they were asking you for the y-intercept of this line, just read the instructions in the problem to see if they want you to say 5 or if they want you to say 0, 5. Sometimes they want you to answer as an ordered pair, and sometimes they want you to just answer as a number. I personally like to write intercepts as ordered pairs. Okay, here's an example of interpreting information given by graphs. Divorce rates are considerably higher for couples who marry in their teens. This sounds like a the more you know problem. The equation D equals 4n plus 5 models the percentage D of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. And they want me to determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of the marriage. So that is a pretty easy problem once you translate all the words into, you know, what you're actually supposed to do, which is usually the hard part of any word problem. So to determine that percentage, we're going to take the equation D equals 4n plus 5. And they wanted to know specifically what is that percentage when n is 15. So we're just going to fill in 15 for n. And when I fill in 15 for n, I get the D is 4 times 15 plus 5. 60 plus 5 is 65. So according to this model, if the wife is under 18 years old at the time of marriage, the percentage of marriages that will end in divorce after 15 years is 65%. So it's a pretty high number. Okay.